In this module, we shall learn about one of the most important processes for manufacture of glass, that is the float glass process. Now, since the beginning, when the earth has been formed with a big bang, nature gave us a substance which has now become an integral part of our lives, that is the glass. But do you know how the glass has been formed? No, we don't know how the glass was discovered. Maybe by chance a lightning might have struck in a patch of sand, or maybe some prehistoric nomads must have found the hard, shiny substance in the ashes of fire. But while we do not know how it had been discovered, the process for the manufacture of this substance, which we call glass, is now becoming perfect over centuries through sheer human efforts and technical knowledge. Today, glass, which has now become an integral part of our lives, is recognized as the most trusted, the most versatile and 100% recyclable packing choice. As an example, let us consider the most important and the most famous Africa's leading glass manufacturing company, Console Glass. Now, this company has been synonymous with glass packing for over 65 years now and is now leading the world. Making glass requires nothing but the correct recipe to mix the raw materials. Now, let us see how the raw materials have been mixed and which raw materials are mixed. Now, in this case, basically, in the manufacture of glass, the materials like sand, soda ash, soda lime and other ingredients such as iron and carbon, which provide color to the glass, they are mixed together so that making glass requires a correct recipe for a correct result, that is a perfect result. What we want, that our glass should be a perfect material. Now, glass, how glass is made? To make glass, certain raw materials are mixed with a specific ratio. Those raw materials are soda ash, limestone, calcium oxide and other ingredients. Now, the other ingredients are nothing but ingredients which are some metal oxides which provide color to the glass. And these oxides, apart from providing color to the glass, they may enhance some of the properties of the glass, like optical properties of the glass. Now, glass is nothing but a amorphous solid material which is often transparent and has got a widespread applications in technological and decorative usages like window panes, decorative glasses, decorative items and in optoelectronics. Now, the most familiar and maybe historically the oldest types of glass, which is based on the compound silica, which is nothing but one of the major ingredient of sand. For example, many silica based glasses that exist in nature, for example, the ordinary glass, which is nothing but a glazing or a container glass, is nothing but it is formed from a very specific type of glass, which is the soda lime glass, which is made up of 75% of silicon dioxide and some percentage of calcium oxide and sodium oxide and various other minor additives. Now, coming to the major processes that are being involved in a glass manufacture. Basically, the manufacture of glass involves two different types of processes. One is the float glass process, which is required for manufacturing sheet glass, and the other is the glass blowing process, which is required for the manufacture of glass containers and bottles. In this module, we are going to cover with what is known as the float glass process majorly. But we will also give a brief description of what a glass blowing process is. Now, the float glass process is nothing but used for producing a sheet glass, and this is achieved by taking a 500-meter long furnace, and this furnace, from one side of the furnace you keep on adding the raw materials, and on the other side the molten glass is being drawn. Coming to a brief description of glass blowing process. Now, glass blowing process is nothing but a glass forming technique which involves inflating the molten glass out of the furnace into a bubble with the help of a blow pipe. The person who blows the pipe is called a glass blower, while a lamp worker manipulates the glass with a torch on a very small scale to get precise laboratory glassware.
As a type of evidence, glass can be very useful contact trace material in a wide range of offences including burglaries and robberies, hit and run cases, murders, assaults, criminal damage and thefts of and from motor vehicles. All of these offer the potential for glass fragments to be transferred from anything made from glass which breaks to whoever or whatever was responsible. Variation in manufacture of glass allows considerable discrimination even with tiny fragments. Research has indicated that 60% of cases involving glass provided some positive evidence, and that in 40% of these cases this evidence was strong. Depending on the circumstances, the findings can also refute the allegation that a person was involved in a crime. For example, when a pane of glass is broken, minute glass fragments can be showered onto hair, clothing, and footwear of people in close proximity, at least 1.5 and possibly up to 3 meters away. The number of fragments transferred decreases rapidly with distance from the breaking pane. Aside from backwards projection of fragments towards the breaker, the fragments can also be acquired, for example by climbing through the broken window or treading on pieces of broken glass. Fragments of glass recovered from hair and clothing are generally in range of 0.25 to 1 millimeter. Most glass is lost fairly rapidly depending on the activity of the wearer and the texture of their clothing. For example, a woolen jumper will tend to retain glass fragments for far longer than a leather jacket, although fragments can be trapped in pockets, in crevices, on the shoes upper, and remain embedded in shoe soles for long periods of time. The manufacture of glass involves the mixing of silica, soda ash, sand, lime, and salt, etc., and other oxides that further enhances the properties of glass. The float glass method. The float glass is just a plain sheet of glass which is prepared by floating liquefied glass on a bed of molten metal. In fact, modern windows are made by float glass. Maximum float glass is soda lime glass. Sir Alistair Pilkington was the first person to develop the process of float glass. Until the 16th century, window glass or flat glass was generally cut from large discs of crown glass. Larger sheets of glass were made by blowing large cylinders which were cut open and flattened, then cut into panes. Most window glass in the early 19th century was made using the cylinder method. The cylinders were 6 to 8 feet long and 10 to 14 inches in diameter. limiting the width that panes of glass could be cut and resulting in windows divided by transomes into rectangular panels. The first advances in automating glass manufacturing were patented in 1848 by Henry Bessemer, an English engineer. His system produced a continuous ribbon of flat glass by forming ribbon between rollers. This was an expensive process as the surface of the glass needed polishing. If the glass could be sent on a perfectly smooth body, this would reduce cost considerably. Attempts were made to form flat glass on a molten tin bath, notably in the US. Several patents were granted, but this process was unworkable. Before the development of float glass, larger sheets of the plate glass were made by casting a large puddle of glass on an iron surface and then polishing both sides, which was a costly process. From the early 1920s, a continuous ribbon of plate glass was passed through a lengthy series of inline grinders and polishers, reducing glass losses and cost. Glass of lower quality, sheet glass, was made by drawing upwards from a pool of molten glass a thin sheet held by the edges by rollers. As it cooled, the rising sheet stiffened and could then be cut. The two surfaces were of lower quality, that is, not as smooth or uniform as those of float glass. This process continued in use for many years after the development of float glass. Between 1953 and 1957, Sir Alistair Pilkington and Kenneth Bickerstaffe of the UK's Pilkington brothers developed the first successful commercial application for forming continuous ribbon of glass using a molten tin bath on which the molten glass flows unhindered under the influence of gravity. The success of this process lay in the careful balance of the volume of glass fed into the bath, where it was flattened by its own weight. Full-scale profitable sales of float glass were first achieved in 1960. Now, the major stages involved in the method of manufacturing float glass are shown. Let's study these steps in detail. The first step is mixing of raw materials or batch. The ingredients used for making glass are stored properly to uphold the high standards of the consistency of composition and to keep it free from impurities. The raw materials are weighed properly and mixed thoroughly before being put into the furnace. All the major ingredients like soda ash, silica, etc., and minor additives present in the charge or batch are delivered to the furnace. Cullet or waste glass is also an important raw material that assists the melting process. Next is glass melting. The raw materials, that is both batch and cullet, are heated in a furnace to about 1500 degrees Celsius. The furnace is constructed of refractory blocks which can withstand the temperatures of more than 1500 degrees Celsius and the corrosive nature of molten glass. The greatest percentage of glass is melted in tanked furnaces to produce continuous flow of glass to be fed to the automatic glass forming machine. The third step in float glass method is refining and homogenizing. While the raw materials are melting in the furnace, gases like carbon dioxide are emitted and they react. The liquefied glass should be kept at a temperature which is high enough to permit all the glass bubbles to rise to the surface and hence are eliminated. This elimination takes place in the refining stage as the melted glass passes through the furnace. When the glass is sufficiently refined and homogenized by removing the bubbles and impurities, the temperature of the molten glass is reduced to 1100 degrees Celsius as it passes down the furnace towards the forming stages. This process is important for producing high quality glasses and can last up to 50 hours. Glass does not have any certain melting or freezing point, but it changes progressively from viscous liquid to a rigid solid as its viscosity increases on cooling. Next step in the process is glass forming or the float bath. The melted glass flows from the furnace onto the molten metal like tin and then form a ribbon of about 6.8 mm thickness. Later, it flows over molten tin and is cooled to 600 degrees Celsius when it leaves. Thicker glass of up to 25 mm thickness can be further produced by not allowing to settle at 6.8 mm. The ribbon is thus stretched to produce thinner glass. In other words, it is the steady and constant change in the viscosity with respect to the temperature which permits molten glass to be converted into large number of products. Thus, in an appropriate range of viscosity, molten glass can be subject to many different processes to make products ranging from flat sheets several square meters in area to filament with diameter less than that of a hair. Annealing is the step followed by the method of float bath. Although glass contracts on cooling like other materials, but due to its low thermal conductivity, it does not cool uniformly, which can produce uncontrolled stress in the glass and can break the glass. This undesirable stress can be avoided by slow and controlled cooling, which is the annealing process. Annealing is carried out in a part called layer, through which the glass passes on a slow moving conveyor. When glass products have been formed, annealed and cooled to an appropriate temperature, they are subjected to a range of finishing products. After annealing, toughening or tempering is done. In order to avoid breaking, glass is thermally strengthened by inducing compressing stresses in the outer surfaces. Toughening is carried out by reheating the glass uniformly to a temperature just above which deformation can take place and then rapidly cooling the surfaces. Although cooling chills the outer layers while the center of the glass is still hot. As the center of the glass cools, it contracts, pulling the rigid surface layers into compression, which is further balanced by the tension in the inner layer. Next is coloring and decolorizing. Unless the raw materials are pure, glass made from silica and other raw materials will appear green. The coloration depending mainly on the amount of iron oxide and other impurities. But for some products, the manufacturers decolorize the glass by adding small amounts of colorants which are complementary to green color so that the finished articles appear to be colorless. The last step is that of cutting. The final stage of glass making is cutting, in which diamond wheel cutters are used to cut the glass made to the required size. Customer requirements are fed into the computer to find out the best way to cut the glass to avoid waste.
Let us now summarize what all we have learned in this module. In this module, we have learned the most famous, the most important, one of the oldest method, that is the float glass method for the manufacture of glass. This method was introduced by Sir Alistair Pilkington in 1952 and is now used to manufacture flat glass. Let us now come to the glass manufacturing process. It consists of 6 different stages. Let us summarize each stage one by one. The first and the most important stage is melting and refining. That is, all the raw materials, for example, your silica, sodium oxide and calcium oxide, that is the lime, they are mixed together to form what we call as batch, and this batch flows into the furnace at a temperature of 1500 degrees Celsius. Now, while adding the raw materials, we can also add some metal oxides which impart color to the glass. For example, oxides of nickel and cobalt, they give a grey tint, while oxides of selenium is going to give a bronze tint. Now, apart from these raw materials, color additives, some broken glass is also added while the glass is being manufactured, which does nothing but reduces the temperature, the melting point of the batch. This is also called as the flux. Coming to the second stage, which is nothing but float bath, that is, glass from the furnace is actually flowing on a mirror like surface of molten tin, starting at 1100 degrees centigrades and leaving the float path as a solid ribbon at 600 degrees Celsius. That means the temperature has been reduced from 1100 degrees Celsius to 600 degrees Celsius. Coming to the third part, which is the coating of the glass. Now, basically the coating is being done to enhance and change the optical properties of the glass, and this is done by advanced high temperature technology, for example, online chemical vapor deposition. Coming to the stage 4, that is annealing. So, the glass is made to move through the annealing layer where the internal stresses which have been developed while manufacturing the glass, that is while the glass is coming out of the furnace. So, in this case now these internal stresses are removed as the glass cools gradually to make the glass more prone to the cutting. Coming to stage 5, which is inspection. Now, inspection is to be done at every stage of the manufacture of the glass. This inspection is done to check the quality of the glass, that is, whether the glass which has been manufactured is a high quality glass or a low quality glass, and whether a bubble has been removed during refining or not, whether some small sand grain has been left and it melts. So, for this purpose, online automated inspection is being done. Now, coming to the last process, which is the cutting. For that, since the glass has now become a hard object, so for that is for cutting the glass, diamond steel trims off the stressed edges of the glass and it cuts the hard ribbon to size the glass accordingly. What is the requirement? That is, whether we want a flat glass and what should be the measurement of the flat glass that we want. This is being actually fed to the computer. So, glass is finally sold in square meter.